Hello, this is a continuation of the Level 2 Mathematics and Statistics examination from 2025 91262, Apply Calculus Methods in Solving Problems. The previous video I covered question 1, so today in this video we will cover question 2. So let's just move down to question 2 and see what we've got. So here are the solutions we had previously for question 1. And now we've got question 2. It says, given a graph, f of x below, sketch f prime of x here. So below, which is down here, empty graph. Sketch means it doesn't have to be accurate. There's no scale given on the graph above. So we can just draw our graph in as we see fit. There's two important things. So f prime of x is the gradient function of f of x. So we're plotting down below the gradient of this function. Two important things. So where there is a stationary point, of the function of, I said the function, but let's call it what it's called, of f of x, then f prime of x has a 0. That means it cuts the x-axis. So let's do those ones first. Here are the stationary points, the turning points. Stationary points could be points of inflection, so not always turning points. And that means below those points, so directly below those points, we've got 3 points on the curve where it cuts the x-axis. And the second feature that we want to plot is where f of x slopes down, f prime of x has to be less than 0. And where f of x slopes up, f prime of x is bigger than 0. So this one's below x-axis. This one's above x-axis. That is above the x-axis in the graph of f prime of x and below the x-axis. And f prime of x is nothing to do with whether this is above or below the axis. Nothing to do with f of x. So what have we got? We're sloping down here. We're sloping down here. That means we're below the x-axis. So in this region, we can't be above the x-axis. In this region, we can't be above the x-axis. Let's continue these down. And let's say red. We're going up here, we're going up here. That means those ones we can't be below the axis. We can't be below the axis. And now you just have to fill in your sketch. we have to be down here somewhere. We've got to go up. We've got to go down. We've got to go up. So we get a cubic type function. I haven't worried about the scale. You could argue that the scale here is about 1, cross 1, up 1. And then it would depend how many of these make up 1 unit to know how high. So there's no real way to determine how high up we go. It's really just it's a scaling issue. We could go steeper, we could go flatter. Our sketch would still be okay given the information that we've got. So that's question 2a. For the function f primed, the derivative is 2x cubed minus 6x squared plus 2x plus 4. The graph passes through 2, 5. Find the equation of this function. This is an integration question. We're given the f primed, the derivative, and we need to find the original function. So the original function is going to be the integral of the derivative. So that's the integral of 2x cubed minus 6x squared plus 2x plus 4. When you integrate this, add 1 to the power, so it's 2x to the power of 4 divided by the new power. Add 1 to the power, 6x cubed divided by the new power 3. Add 1 to the power, it becomes 2x squared divided by 2 plus 4x, x to the power of 1 divided by 1, we don't have to write that in, and then there's always an arbitrary constant when we do an integration. And because there's an arbitrary constant, then if we want to find the exact function, we need to have some more information. So it tells us that the function f of x passes through 2, 5. So now we can evaluate the constant c by looking at the function when x is 2. We can do a bit of cancellation. 2 over 4 is the same as x to the 4 over 2. 6 over 3 is the same as 2. 2 over 2 is cancelled out. So now we get 2 to the power of 4 divided by 2 minus 2 times 2 to the power of 3 plus 2 to the power of 2 plus 4 times 2 plus c, and we're told that that value is 5. 2 to the power of 4 divided by 2 is 2 to the power of 3, so that's going to be 8. 8 times 2 is 16, plus 4, plus 8, plus c equals 5. 8 and 8 is 16, minus 16 is 0, so c is going to be 5 minus 4, which is just 1. We want the equation of the function, so that's going to be x to the power of 4 divided by 2 plus x to the power of 3, it's 2 of those, minus this, plus x squared plus 4x plus 1. And we're done there. Hemi is part of a student research project on how caffeine enters the bloodstream. A new device measures caffeine levels in his blood. He is monitored for 180 minutes, 3 hours, and at some point he is given a cup of coffee to drink. His caffeine levels can be modelled using the equation t cubed over 150 minus 1.4 t squared plus 80t plus 240. We see this as the concentration in micrograms per litre, and t is the time in minutes. Show that the rate of change of concentration is minus 16 micrograms per litre per minute after he has been there for 60 minutes. The rate of change, that's the derivative. Let's just shift that down and give us some space to work. So we want the rate of change, that's the derivative. So we differentiate the concentration, that will tell us the rate of change. Multiply by the power, reduce the power by 1. That will cancel 3's into 150 is 50 minus multiply by the power 2.8 T plus 80, and the 240 goes to nothing. We want the concentration after 60 minutes, so that's 60 squared over 50 minus 2.8 times 60 plus 80. You can just throw all that into your calculator if you want. This is 3600 divided by 50 minus times 10 is 2.8 times 6. 6 2's are 12, 6 8's are 48. It looks like 168 to me. Plus 80. Cancel 5's into 36 is 7. There's 1 over 72. So that's 72 plus 80 is 152. And that's another 16. So this is equal to ND minus 16 micrograms per litre per minute as required. I bet you can do that on your calculator. You're probably more comfortable doing that, but it's a good practice when you're practicing problems to try and do as much in your head as you can. It'll give you extra confidence when you get them correct, and I think you'll actually find most of the time, unless it's a very complicated calculation, you can be as quick or quicker doing manual calculations. Use calculus to justify when Hemi was given the coffee, assuming the caffeine enters the bloodstream as soon as it is consumed and continues to increase for some time after consumption. So this is we want the turning point here. We want when the concentration begins to rise. That is, i.e., where is the turning point? It's got to be a minimum, or maybe a point of inflection, I suppose. Because the caffeine level is going to start going up after it's consumed. So it's consumed, comes into your stomach, goes out into your bloodstream, and as it gets absorbed into your bloodstream, the caffeine level will rise. So we want to find the turning point. So that's the derivative that we found, which was t squared over 50 minus 2.8t plus 80. We want to find when that's 0. I don't like fractions, so my standard strategy, and recommended, I think, is when you've got a fraction, just multiply through by that 50. So we get t squared here, multiply this by 10, gives us 2.8 times 5. 10 will give us 28. 28 times 5. 5 20s are 100. 5 8s are 40s, 140t. And multiply by 50, 5 8s are 40. we need to find a factorization of this. And it looks like 140. T minus 40. T minus 100. 100 times 40 will give us 4,000. Minus 100 and minus 40 gives 140. So T equals 40 or T equals 100. And we want which one's going to be the minimum. We started off with a quadratic. We looked at this before. When the coefficient of T cubed is positive, the quadratic goes like this. So the first point will be a maximum and the second point will be a minimum. So this one's a maximum, this one's a minimum, and it's the minimum that we want. You can use calculus to do this, well, a more maybe formulaic approach of calculus. Find the second derivative. So you've got t squared over 50, so it's 2 times t over 50, which will be t over 25, and then minus 2.8. That's the derivative, and we can evaluate it at both of these points. So the derivative at 40 is 40 over 25 minus 2.8. That's got a 5 in it, that's got a 5 in it, that's 1.3 minus 2.8. Don't care, it's less than 0. So that's a maximum. At 100, it's going to be 100 over 25 minus 2.8. It's 4 minus 2.8, which is bigger than 0. So this one's the minimum. So we can assume at the minimum, coffee. It says as soon as you start drinking the coffee, it gets absorbed and the caffeine levels will rise in the bloodstream. So yeah, this is indeed the one we want. Part D, a function is given by f of x. We've got some parameters in there, ax cubed plus bx squared plus ax plus 2, where a and b are constants. The graph of f of x intersects the x-axis at x equals 1 and has a stationary point at x equals negative 1. So use calculus to find the coordinates of the other stationary point. Yeah, let's just go through. So we've got f of 1 when x equals 1. It cuts the x-axis, so that means y is 0. That's going to be 0. And that's going to be a, 1 cubed is 1, plus b, 1 squared is 1, plus a, 1 times 1 plus 2 has to be 0, so that's 2a plus b plus 2, and I'm going to write the 0 over here because we're going to use the equation in this form. The derivative that will tell us where the stationary point is, or stationary points are 3a x squared plus 2b x plus a, and the constant vanishes. And we're told that the derivative at x equals negative 1, 3a times negative 1 squared plus 2b times negative 1 plus a, we're told that is 0. Negative 1 squared is 1, so that's 3a. I've got another a over here, so that's going to be 4a. And this is going to be minus 2b equals 0. So we've got these two equations, which we can solve simultaneously to find a and b. If I double equation 1, so 2 times equation 1, and then add equation 2, that's going to give me 2b here and minus 2b here. We'll eliminate the b, so 4a plus 2b plus 4, that's doubling that, and then add on this one, plus 4a minus 2b. Both got 0 on the right hand side, so 2b cancels with the minus 2b, so we get 8a plus 4 equals 0, a equals negative 1/2. And then we can substitute that into either of these equations to find out the value of b. So let's put it into equation 2. 4 times negative 1/2 minus 2b equals 0. Now the b can go on the other side. B divided by 2 is going to be 2 times negative 1/2 is equal to negative 1. Minus 2. This is minus 2 minus minus 2. It's going to be 0, that's right. So we found the equation of the curve. So our equation is now f of x equals a minus 1/2 x cubed plus b minus x squared minus 1/2 x plus 2 equals 0. I think I like to multiply everything by 2 and maybe even a negative sign. So that implies if I multiply by 2, I get negative 2 multiplied by negative 2. I get x cubed plus 2x squared plus x minus 4 equals 0. And we know that, negative 1, isn't it? Negative 1 is a stationary point, so that's one factor. I'm looking at, it's not the 0, so I've done the wrong thing then. That's the right f of x. Now the derivative is minus 3 over 2x squared minus 2x minus 1/2. And we want that 0 to find the stationary points. Now if I multiply by negative 2, so multiply by negative 2 again, I'm going to get 3x squared plus 4x plus 1 equals 0. We know that x plus 1 is a factor, so the other factor is going to have to be 3x to get this, plus 3x. I need another x, so plus 1 to give me 4x, and then plus 1, that works out. So this is x is negative 1 as we found, and x is equal to negative 1/3. So this is the other stationary point. Just says the x coordinates, so we've done enough. And then it says use calculus method to determine what type of stationary point this is. So we've done this another number of times already in this exam, but we've got here, well, let's not, we don't know what the values are. We've got here a cubic that goes like this. A cubic's got a negative. this is the other case where our coefficient of x cubed is negative. Our cubic is going to look the other way. So that means that we've got a minimum on the first one and a maximum on the second one. This one is at x equals -1, and this one's at x equals -1/3. So this is going to be a maximum. But it did say use calculus, so part 2, we take our derivative. Here's our derivative. If we find the second derivative, 2 times this, it's going to cancel that 2, so it's minus 3x and then minus 2. We want to know what's happening when the x value is -1/3, so it's minus 3 times -1/3 minus 2. This is positive. It's 1 minus 2, which is clearly less than 0, which implies that we have a maximum, which is what I said here. And if you check the other one, it's not required, but -1 minus 3 times -1, that's 3 minus 2. That's bigger than 0. So that implies we've got a minimum, which is what I suggested up here. Perhaps just this factorization that I did here. What I've done, we've got the derivative. Multiplying through by -2 doesn't change where the roots are, but it gives us a quadratic that's easier to work with. We're told that this is a minimum, so I need to just find what that needs to multiply to give this. To get 3x squared, I have to have a 3x term here. 3x times x is the 3x squared term. Then that gives me plus 3x, but I want plus 4x, so I have to add another 1. Tells me the right thing here. And then just the last bit is a double check. 1 times 1 gives 1. There are other ways you can do this. You can do long division if that's what you've been taught. So you could go x plus 1 divided into 3x squared plus 4x plus 1. You could do this into the quadratic with fractions in it. The working is going to look messier if you do that. So it really is a good idea to multiply through by the 2, and multiplying by the negative sign might help as well. So we're all better. We can't avoid negative signs altogether, but we're all better working with positive numbers. So x goes into 3x squared 3x times. 3x times x is 3x squared. 3x times 1 is 3x. You do a big subtraction, that gives us 0 here and gives us x here. You bring down the 1, x plus 1 goes in here 1 time, and this is the other factor that we found. So there's 2 methods to factorize there. I guess your calculators can help you as well. And now we're on to question 3. So that's question 2 done. Any questions, put them in the comments, and I'll do my best to revisit them and see how I can help. Okay, until next time when we do question 3, I will see you later.